Welcome to Lesson 2.1 of the Enchanted Interpreter. So far in our lessons, we've been working with text data. In Python, these are known as strings. In today's lesson, we'll learn about numeric values in Python and how we can work with them. And yes, I'm talking about math, but don't worry, we can make our programs do the work for us. So here's a question. What's the difference between this value and this one? It might not look like there is one, but to the interpreter, those are two completely different things. Everything in Python has a type. The type tells Python what kind of thing it's working with, and different types behave differently, and there's different things that you can do with them. Think of the labeled jars from the last lesson. A jar labeled sugar and a jar labeled salt might look the same, but you'd use them very differently. We've been working with strings so far. Today we're adding in the numeric types, integers and floats. An int, short for integer, is a whole number, a number with no decimal point. It can be positive, negative, or 0. So these are all examples of integers, 5, -3, 1, and 10,000. A float, on the other hand, is a number with a decimal. It can also be positive, negative, or 0, 3.14, -0.5, 0.0, and 2.0. Now these last two examples look like they should be integers, don't they? There's no decimal value. But in Python, 2 is an integer, 2.0 is a float. They're treated as different types, even though mathematically they have the same value. We'll see why that matters in a moment, but first I want to demonstrate something a little funky about floats. Try running the following. Print 0.1 plus 0.2. So we'll save it and run it. Py lesson.py. You'd expect to get 0.3, right? This isn't a typo or a Python bug. It's actually a floating point representation issue that affects almost all programming languages, not just Python. Your computer stores decimal numbers in binary, and some values can't be represented with perfect precision. For most things you're doing, it's not going to matter, but I wanted to point it out now in case you come across it and think you broke something somewhere. We've been working with strings already, but I wanted to look at them again and the example I gave earlier. Example 2 here is a string. It's just text. Python doesn't know that you want it treated as a number. It's just text that happens to look like one, which means you can't do math on it. Here I have hello, 5, and 3.14, all in quotes. Without the quotes, this would be an integer, and this would be a float. But because they're inside quotes, they're all strings. The quotes are what make them strings, regardless of the text inside them. Pause the video for an exercise. Create 3 variables, one int, one float, and one string, with names that make sense for what they're holding. Then print all 3. Here's how mine looks. I decided to stick with the witchy theme. So I've got a potion count, an ingredient weight, and a keeper name. So far we've just been printing strings, but you can print other data types as well. So to print the potion count and the ingredient weight, we just need to put those inside the print statement just like we do with keeper name. So if I go ahead and run this, you see my potion count, my ingredient weight, and the keeper name. That's simple enough. Now let's do some math. Addition, subtraction, multiplication, which uses the asterisk, and division, which uses the forward slash, all behave exactly how you'd expect. Division has one thing worth noting, though. If we run this, we get the results that we'd expect here. But what if we add print 10 divided by 2? Should give us 5, right? We get 5.0, a float, not an integer. Division in Python always returns a float, even when the result is a whole number. What happens when you combine an int and a float in the same operation? Let's try a couple. We'll do 3 plus 1.5. Run that one. And we get 4.5. We got a float back, but that's to be expected because that's the solution to the problem. What if we change it to 3 minus 2.0? We should get 1, and we get 1.0. When you mix an int and a float, Python's going to return a float. So if any part of your operation includes a float, you can expect to get a float back. In an earlier lesson, we talked about concatenating strings. It's important to understand the difference between concatenation and addition. In Python, you can concatenate strings together like I've done here. If we run this, we see hello world. What if we tried to do print 5 plus 3? Let's run that one. Oh, and I have the space here. That's not what I meant to do. Try that again. All right, printing 5 plus 3 gives us 53. This is because this 5 and this 3 here are both strings. So Python doesn't add them, it concatenates them. It takes the characters from the second string and sticks them onto the end of the first string. And if you try to mix a string and a number, so let's take the quotes off of the 3 here, save that and run it, we get this error. Python doesn't know whether you want to concatenate the values, giving 53, or add them, giving 8. And errors can be intimidating, but I think learning to work with them is really important. So I'll kind of walk through what the error is telling us here. So first you'll get where your error is located. So I'm in this file, lesson.py. Line 50 is where the error came up. And then we have the actual line with an indicator on what piece of code broke your program. And you can see this little arrow under the plus sign. Then below that you have the type of error. So in this case it's a type error. And usually a little message that gives you more information about the error. So here we have can only concatenate string, not int, to string. If I were to change this 3 to 3.0, run that again, can only concatenate string, not float, to string. So it knows that I have a float and a string here. It just isn't able to add them together or concatenate them. If I change the 3.0 back to a string or change the 5 to an integer, then I can do math with it. And because I'm doing an integer and a float, I get 8.0 instead of just 8. So the plus operator with numeric types will add them, and with strings will concatenate them. And you can't mix the two. Up until now, we've mostly been doing math directly inside of our print statements, which is fine for quick experiments, but in real programs, we usually want to store the result back in a variable so that we can reuse it later. So instead of doing something like this, where we're printing 1999 plus 160, we would do something like this. Say price is 1999, tax is 160, total is price plus tax, and then we would just print the total. So if we run this, we see both print the same result, 2159. So what's actually happening on line 60? In an earlier lesson, we talked about how the Python interpreter evaluates what's on the right before it saves that value back in our jar, or our variable. So here, we're going to take the price variable, and it knows that's 1999. It's going to add to it the tax, which is 160, and then it takes that result, 2159, and saves it back inside the total variable. We can prove that by printing everything. So here we'll add print price and print tax. And if we run that again, and we can comment out this first print statement. And if we run that again, oh, I didn't save it. There we go. We see the price is $19.99, the tax is 1.6, and the total is $21.59. Price and tax stayed the same, but the total has the evaluated result. We covered this in an earlier lesson as well, but I just wanted to touch back to it. Using a variable to update itself. So if we say score is equal to 10, we can then say score is equal to score plus 1. Now if we print score, we see the total is 11. So it's taking this value on the left, which is score plus 1, and it takes our current score, which we've set to 10, adds 1 to that, which gives us 11, and then it saves that 11 value back in the score variable. So it's just taking the current value, adding to it, and then updating the value. Now let's try an exercise. You're running a potion shop where a customer buys 3 healing potions at $12.50 each and 2 mana potions at $9.75 each. There's a 6% sales tax. So create variables for the healing potion price, the mana potion price, and optionally the quantities. Then calculate the total before tax, the tax amount, and the final total, and print those 3 values. Pause the video and give it a try. How'd you do? Here's how I did that exercise. I saved the price of each potion in its own variable, so healing potion price is 12.5 and mana potion price is 9.75, and then the 6% sales tax I saved in a variable called tax, and I saved that as 0.06. Then the healing potion total is the healing potion price times 3. Then the mana potion total is the mana potion price times 2, because they're purchasing 2 mana potions. The subtotal is the healing potion total plus the mana potion total, and the tax amount is the subtotal times the tax. Then for the final total, we just need to add the subtotal plus the tax amount. And then to print that, I printed this statement, your subtotal is, and then our subtotal inside an F string. After tax amount tax, your final total is, and then here I didn't use the final total variable I created because I wanted to demonstrate something else. With F strings, you can do calculations inside your curly brackets. So instead of saying final total, I can just put subtotal plus tax, and the interpreter is going to evaluate that first before it prints our string, because it can simplify that. So it's going to simplify that value, and then it will have a value it can put back into the final string that it prints. So if I save this and run it, your subtotal is $57. After $3.42 tax, your final total is $57.06. And that is not quite correct because I'm adding tax here instead of tax amount. So let me fix that and run it again. Your final total is $60.42. That sounds right. We've talked about how regular division always gives you a float. But what if you actually need a whole number? That's where floor division comes in. Floor division is done by using 2 forward slashes instead of 1. And what it does is divides and then drops the decimal value. So whatever comes after the decimal point just gets cut off. So if we do 17, we use floor division to divide it by 5. Let's run that. We get 3, not 3.4, just 3. Floor division answers the question, how many groups fit into this number? How many groups of 5 fit into 17? Say you have a program that tracks time in seconds, but you want to display it in minutes. So we could say we have total seconds is equal to 367. How do we turn that into minutes? If we just divide total seconds by 60, I can comment this one out, we get 6.1166666, several sixes, which is mathematically correct, but not super useful for what we're trying to do. We don't want 6.116 minutes, we want the number of minutes and the number of seconds. So we actually need 2 pieces of information, how many full minutes and how many seconds are left over. We can use floor division for the minutes. To get the seconds, we can use the modulus operator, which is the percent sign. For getting the minutes, we can say minutes is equal to total seconds, floor division, divided by 60. We can print the minutes. And I'm still printing that first value, but we can see the minutes is 6. Floor division asks how many groups of 60 fit inside 367? The answer is 6, and it throws away the decimal. No fractions or rounding, just the full groups. The modulus operator gives us what's left over. Let's comment these out. So we can say seconds is equal to total seconds, which I shouldn't comment out. There we go. Mod, which is the percent sign, 60. So the modulus operator says after making the full groups, what's left over? When we combine them, we can get the total minutes and seconds from our initial value. So we can print there are minutes, and seconds, in total seconds. If we run that, there are 6 minutes and 7 seconds in 367 seconds. Now let's try another exercise. You've brewed 40 ounces of a potion, and you're putting it in vials. Your vials hold 6 ounces each. Pause the video and see if you can figure out how many vials you can get from this batch of the potion, and how many ounces will be left over. Print your result. Here's how I did it. I created variables for the data I knew, so the brewed potion amount, 40 ounces, and the vial capacity, 6 ounces. Then I created variables for the data I needed to calculate. How many vials we can fill, which is a brewed potion, floor division, vial capacity, and how many ounces would be left over. So ounces remaining is the brewed potion mod the vial capacity. And then I added a print statement showing the results. You can fill the amount of vials, and there will be ounces remaining left over. So if we run this, you can fill 6 vials and there will be 4, should be ounces left over. We can double check by doing some quick math. If we multiply the vial capacity by how many we filled, we get 36. That's 36 ounces of potion used, and 40 minus 36 is 4, which matches what we have remaining. One more thing before the challenge. Python follows standard mathematical order of operations, which you probably learned as "Please excuse my dear Aunt Sally," parentheses, exponents, multiplication and division, addition and subtraction. If you're comfortable with the order of operations from math class, Python works exactly the same way. So here we have print 2 plus 3 times 4. What do you think the output will be? If we save this and run it, we see it's 14, not 20. Python evaluates the 3 times 4 first because multiplication and division comes before addition and subtraction. If you wanted 20, you would need to add parentheses. So we'll add parentheses around 2 plus 3 to say do this first, and then multiply that result times 4. If we run it again, we get 20. While we're talking about order of operations, let's look at one more operator. Using 2 asterisks is how you do exponents in Python. For example, if I wanted to do 2 to the power of 3, I would type it like this: 2, and then 2 asterisks, and then 3. So the first number is your base, and the second number is your exponent. And you use the 2 asterisks to indicate that you're doing exponents. So if I run this one, we get 8. 2 times 2 times 2, or 2 to the power of 3, is 8. All right, that covers numbers and arithmetic. You've got the building blocks now. Head to the GitHub repo linked in the description for the story content and the challenge. A solution is posted there too, but give it a try first. Good luck, and I'll see you in the next lesson.